Hello! Today, we're going to explore the fascinating world of exponents and roots. By the end of this video, you will be able to understand and apply the rules of exponents, work with fractional powers, and calculate square roots of various numbers. Our main goals are to understand exponents, fractional powers, and square roots. Let's start with a quick recap of what an exponent is. An exponent tells you how many times to multiply a base number by itself. For example, in the expression 2 to the power of 3, 2 is the base and 3 is the exponent. This means we multiply 2 by itself 3 times. So 2 times 2 is 4, and 4 times 2 is 8. Therefore, 2 to the power of 3 equals 8. Now, let's quickly review a couple of key rules. First, the product rule. The product rule states that when you multiply two powers with the same base, you add the exponents. For example, 2 to the power of 3 times 2 to the power of 4 is 2 to the power of 3 plus 4, which is 2 to the power of 7. Next, the quotient rule. The quotient rule says that when you divide two powers with the same base, you subtract the exponents. So 2 to the power of 5 divided by 2 to the power of 2 is 2 to the power of 5 minus 2, which is 2 to the power of 3. And finally, the power rule. The power rule states that when you raise a power to another power, you multiply the exponents. For instance, 2 to the power of 3, all raised to the power of 2, is 2 to the power of 3 times 2, which is 2 to the power of 6. So we've quickly recapped what exponents are and three fundamental rules: the product rule, the quotient rule, and the power rule. This foundation will be crucial as we move on to our next topic. Now, let's take our understanding of exponents a step further. What happens when the exponent is a fraction? This is where fractional powers come in. Fractional powers, also known as rational exponents, are a way to express roots using exponents. The general rule is that a number raised to the power of 1 over n is the nth root of that number. In other words, a to the power of 1 over n is the same as the nth root of a. The denominator of the fraction becomes the index of the root. Let's look at some examples to make this clear. First, 9 to the power of 1 over 2. Here, n is 2. So this is the second root of 9, which we call the square root of 9. The square root of 9 is 3, because 3 times 3 equals 9. Next, 8 to the power of 1 over 3. Here, n is 3. This is the third root of 8, or the cube root of 8. The cube root of 8 is 2, because 2 times 2 times 2 equals 8. Let's try one more. 32 to the power of 1 over 5. This is the fifth root of 32. We need to find a number that, when multiplied by itself 5 times, gives 32. That number is 2, because 2 to the power of 5 is 32. So we've seen how a fractional exponent with a numerator of 1 translates directly into a root. This is a powerful connection between exponents and roots. Now, what if the numerator of our fractional exponent is not 1? The rule extends beautifully. The general rule for a fractional exponent m over n is that a to the power of m over n is the nth root of a, all raised to the power of m. Alternatively, it's the nth root of a to the power of m. Let's break this down with an example. Consider 27 to the power of 2 over 3. Here, m is 2 and n is 3. Using the first form, we can write this as the cube root of 27, all squared. First, we calculate the cube root of 27, which is 3. Then, we square that result. 3 squared is 9. So 27 to the power of 2 over 3 is 9. Let's try another one. 16 to the power of 3 over 4. This is the fourth root of 16, all cubed. The fourth root of 16 is 2, because 2 to the power of 4 is 16. Then we cube 2, which gives us 8. So 16 to the power of 3 over 4 is 8. You can also use the other form of the rule, where you raise to the power first. For example, 16 to the power of 3 over 4 could also be calculated as the fourth root of 16 cubed. 16 cubed is 4096, and the fourth root of 4096 is 8. Both methods give the same answer. We've now seen how to handle fractional exponents, connecting them directly to roots. This is a fundamental concept that bridges two important areas of mathematics. Now let's focus on a very common type of root, the square root. The square root of a number is a value that, when multiplied by itself, gives the original number. We use this symbol called a radical to denote a square root. For example, the square root of 25 is 5, because 5 times 5 equals 25. It's important to remember that every positive number has two square roots, a positive one and a negative one. For instance, both 5 and negative 5 are square roots of 25, because both 5 squared and negative 5 squared equal 25. However, when we write the radical symbol, it is understood to mean the principal, or positive, square root. So the square root of 25 is 5, not negative 5. Let's look at some properties of square roots that are very useful for simplifying expressions. First, the product property. The square root of a product is the product of the square roots. For example, the square root of 4 times 9 is the square root of 36, which is 6. This is the same as the square root of 4 times the square root of 9, which is 2 times 3, also 6. Second, the quotient property. The square root of a quotient is the quotient of the square roots. For example, the square root of 100 divided by 25 is the square root of 4, which is 2. This is the same as the square root of 100 divided by the square root of 25, which is 10 divided by 5, also 2. These properties allow us to simplify square roots by factoring out perfect squares. We'll see how to use this in the next section. Now, let's learn a method for calculating the square root of a natural number. We'll start with a smaller number, and then move to a larger one. Our goal is to find the square root of 144. The most common method is to use prime factorization. This involves breaking the number down into its prime factors. First, we find the prime factors of 144. We can divide by 2 to get 72, divide by 2 again to get 36, and so on. The prime factorization of 144 is 2 times 2 times 2 times 2 times 3 times 3. Next, we group the prime factors into pairs. We have 2 pairs of 2's and 1 pair of 3's. We can rewrite this as 2 squared times 2 squared times 3 squared. Now we can apply the product property of square roots. The square root of 144 is the square root of 2 squared times 2 squared times 3 squared. Using the product property, this is the square root of 2 squared times the square root of 2 squared times the square root of 3 squared. The square root of a number squared is just the number itself. So the square root of 2 squared is 2, and the square root of 3 squared is 3. Our expression simplifies to 2 times 2 times 3, which equals 12. Therefore, the square root of 144 is 12. This method works for any number, large or small. Let's try a larger one. Let's apply the prime factorization method to a larger number. We'll find the square root of 1296. Our task is to calculate the square root of 1296. Just like before, the first step is to find the prime factorization of 1296. We can start by dividing by 2 repeatedly. 1296 divided by 2 is 648. Divided by 2 is 324, and so on. We find that 1296 is 2 to the power of 4 times 3 to the power of 4. Now, we group the factors into pairs. Since the exponents are 4, which is an even number, we can easily form pairs. We can rewrite 2 to the power of 4 as 2 squared times 2 squared, and 3 to the power of 4 as 3 squared times 3 squared. Next, we take the square root of the entire expression. The square root of 1296 is the square root of 2 squared times 2 squared times 3 squared times 3 squared. Using the product property, we can separate this into the product of individual square roots. This becomes the square root of 2 squared times the square root of 2 squared times the square root of 3 squared times the square root of 3 squared. Finally, we simplify each term. The square root of each squared term is just the base, so we have 2 times 3 times 3, which equals 36. Therefore, the square root of 1296 is 36. This method is reliable and works for any perfect square. It's a great way to understand the structure of numbers. Let's quickly recap what we've learned today. We started with a recap of exponents and their basic rules. We reviewed the product, quotient, and power rules for exponents. Then, we introduced the concept of fractional powers, showing how they are directly related to roots. We learned that a fractional exponent like m over n means taking the nth root and then raising the result to the mth power. Finally, we focused on square roots, their properties, and a reliable method for calculating them using prime factorization. We saw how to use prime factorization to break down a number and find its square root by pairing up the prime factors. You are now equipped to handle exponents and roots with more confidence. To solidify your understanding, here are 3 homework questions. First, simplify 3 to the power of 5 times 3 to the power of 2. Second, evaluate 64 to the power of 2 over 3. And third, calculate the square root of 225. Thank you for watching, and keep practicing.